Hello, everyone. Welcome to this live tutoring session from Namaste Online Tutoring. I'm Narayan Neupane. So today we are going to talk about the introduction to limits. We are going to look at a couple of examples on introduction to limits from calculus. So without wasting your time, let's get started. Okay, here is our first example. We are learning through examples, okay? Learning through examples and understanding the fundamental concept here. A function f below, so here is the graph of the function given, as you can see. Function f below is defined for all real numbers except for x equal to 3. If you look at the domain of this function, it goes all the way from negative infinity to positive infinity. It is defined everywhere. Okay, it is defined everywhere, but here at 3. At x equal to 3, the function is not defined. What we are asked to do is, what is the reasonable estimate for the limit as x approaches to 3 of this function? If you are asked to find the value of the function at 3, you know that there is no value of the function at 3. Function is not defined at 3. But what is the limit? Let's see if the limit is there. Now, if you think of the left-hand limit, that is, when you approach 3, when x approaches to 3 like that, as I shown here, as it is shown here on the x-axis, when x approaches to 3 from the left, what happened on the graph is going like this. You can see the graph is going like that. And what you'll notice is the y value, or the value of the function, okay, the value of the function over there, if you look at this one, the value of the function is getting closer and closer to -4, because when we go closer and closer to this point here, or when x approaches to 3, the function is going upward like this, and it approaches this y value here, which is equal to -4. So meaning of that is, here the left hand limit, you can write left hand limit, that is limit as x approaches to 3 from the left of the function is a -4. Okay, so the left hand limit is -4. Similarly, if we want to find the right hand limit, what we do is we try to approach 3 from the right. So if the x value approaches to 3 like that, if x value approaches to 3 from the right, you'll see that this graph will go up like this, and it gets closer and closer to that value over there, this y value here. And the y value over here is -4. That means the right hand limit is also -4. So let's write that down. Right hand limit, which is written as limit as x approaches to 3 with a little plus there to indicate that it is coming from the values more than 3, that's from the right. That is also equal to -4. Remember, we are learning the concept through the examples, as I said before. So here the left-hand limit and the right-hand limit both are equal to -4. So if the left-hand limit and right-hand limits are equal, then we say that the limit exists, and that will be equal to these values. So we can say, hence, the limit as x approaches to 3 on that function is equal to -4. So the best estimation for the limit would be -4. The value of the function does not exist, as you can see, but the limit exists. Okay, for the limit to exist at a particular point, it is not necessary that the function is defined. Okay, even if the function is not defined, we'll be able to find the limit. But the key is the left-hand limit and right-hand limit must be equal. Okay, if the left-hand limit and right-hand limit are equal, then the limit exists, and the value of the limit will be equal to that. So here, the limit as x approaches to 3 of the function is a -4. Okay, that is our first example. We'll be looking at 4 examples today. So let's move on to next example. Okay, here is the second example. Again, the graph is given. The function h below, here is the graph of that function h, okay? Below is defined for all real numbers. So this one is defined for all real numbers. What is the reasonable estimate for the limit as x approaches to 0 of h of x? So here we are looking at the x approaching to 0. So what I mean by that is we are approaching 0 over here along the x-axis. When x approaches to 0 from the left like that, when x approaches to 0 from the left, you can see that this graph is going down and then going upward like this, so that the y value reaches to that value 5. Meaning of that is when x approaches to 0, from the left of the 0, the function reaches to 5, approaches to 5. Okay, so meaning of that is the left hand limit is 5. So we can say here left hand limit, which is written as limit as x approaches to 0 with the little minus there. That means we are approaching 0 from the values which are less than 0. That's from the left of this function h of x is equal to 5. Because here, when the function approaches, x approaches to 0, function approaches to 5. The function value approaches to 5. Now let's look at the right-hand limit. That is when we approach 0 from the right-hand side, okay? If we approach 0 from the right-hand side, then you can see when x approaches to 0 from the right, this function is continuously decreasing here. The function is continuously decreasing and approaching a y value, which is -5. It's getting closer and closer to -5. So we can say right-hand limit, okay, that is limit as x approaches to 0 from the right of that function is equal to -5. So you can see the left-hand limit, that's when x approaches to 0 from the left, function approaches to +5. And when x approaches to 0 from the right, okay, you can see that the function approaches to -5. So the left-hand limit and right-hand limit are not equal. Meaning of that is this limit does not exist. So we say since left-hand limit and right-hand limit are not equal, the limit as x approaches to 0 of h of x does not exist. DNE means does not exist. We can write like this. The reason the limit does not exist is because the left-hand limit and right-hand limit are not equal. One more time, for the limit to exist, the left-hand limit and right-hand limit must be equal. Okay, so in the first example, the left-hand limit and right-hand limit were equal. That's why the limit exists and we got the value of the limit. But in the second example, the left-hand limit and right-hand limits are not equal and the limit does not exist. So that is the second example. We are really looking at the fundamental idea about the limit today. We are not looking at the calculation of limits. We are trying to build the fundamental idea on limits. Okay, let's move on to third example. Here's the third one. We can also calculate limits from the table. So here is one situation given to us and we have to estimate the limit again. So let's see. The function h is defined over the real numbers. And the value of function is given here. When x equal to these different values, we have the value of the function given here. Okay. The below gives a few values of h. What is the reasonable estimate for the limit as x approaches to 6 of h of x? Okay, so here we want to find the limit as h approaches to, x approaches to 6. So you can see x is -6.1, -6.01, -6.001. So when you go from here to here, okay, when you go from here all the way up to there, what we see is the value of x is decreasing, you can see the value of x is decreasing and approaching closer and closer to 6. Closer and closer to 6. Okay, closer and closer to 6. Note here one thing, this is a limit as x approaches to -6. That should be -6. That is my typo. Okay, -6. So you can see when x approaches to -6 from this side, okay, here you can see x approaches closer and closer to -6. So -6 can be here in the middle, right? -6.1, -6.01, -6.001, the next value, which will be very, very close after that, should be -6. You can see the same thing on the other side. When you move on this side, the x values are decreasing. Okay, x values are decreasing. -5.9, -5.99, -5.999. So these values are decreasing and approaching closer and closer to -6 again. So x is approaching that -6 from the left and also from the right. Okay, so now we can think of left-hand limit and right-hand limit again. So here, left-hand limit, that is limit as x approaches to -6 from the left. Okay, -6 from the left of that function h of x is equal to, let's look at the values now. So as x approaches to -6, what happened to the value of the function? H of x -0.25, -0.74, -0.98. You can see that these values are approaching -1. Okay, the values are approaching -1. So the left-hand limit is -1. Similarly, if we look at the right-hand limit, you'll see right-hand limit. We write that as limit as x approaches to -6 from the right. The value is greater than -6. So from the right. So if we approach -6 from the right, you'll see that the values are -2.3, then -1.77, -1.02. So you can clearly see that these values are also approaching to -1. Okay, so this is also equal to -1. Meaning of this one is the left-hand limit and also the right-hand limit both approaches to a single value -1. Meaning of that is the limit exists and the value of the limit is -1. So we can say, hence the limit as x approaches to -6 of the function is equal to -1. So we can literally look at the table and we can also determine the value of the limit. Sorry about this typo. This is limit as x approaches to -6 on that function h of x. Okay, so one more time. When the table values are given, it's easy for us. If the function is given, we can still create a table and find the limit. But if the table is already given to us, we can just look at the table, analyze the table, and then find the value of the limit. Okay, let's look at one more example for this session. So here is the last example for this session. The function h is defined for all real numbers except at x equal to 4. So this is the graph of the function h of x, and you can see that it's defined everywhere, but not here at 4. If you go all the way up from the 4, you will not get to the graph. And if you go all the way down, you'll not get to the graph. Okay, so that means the function is not defined at 4, just like in the first example. See, in the first example, the function was not defined at 3. Okay, still the left-hand limit and right-hand limit were equal, and we were able to find the limit. Let's see what happened in the fourth question. The function is not defined at 4. but we are going to estimate the value of the limit as x approaches to 4 of h of x. So let's look at the left-hand limit and also the right-hand limit here. So let's begin with left-hand limit. Here, left-hand limit, we can write like this: limit as x approaches to 4 with little minus sign on the top, which shows that the values are approaching from the left of h of x. What happened when x approaches to 4 here? You can see I'm showing with that red line. When x approaches to 4, you can see that this graph is going all the way down like that without touching anything over here, without touching that vertical line there at 4. That means as x approaches to 4 from the left, the function value approaches to negative infinity. It goes all the way down. Y value will be negative infinity. Y value will be negative infinity. Okay. Similarly, if we look at the right-hand limit, let's see what we get. Right-hand limit, that is limit as x approaches to 4 from the right. That means we are approaching from the values that are greater than 4 from this side. Okay, from the right, when we get closer and closer to 4. When x approaches to 4 from the right, this function, as we come closer and closer to 4, this function goes upward. It goes up all the way without touching that vertical line. It tries to go all the way to the positive infinity. It goes all the way up. That means y value will be positive infinity. Y value will be positive infinity. So you can clearly see in this example, the left-hand limit and right-hand limit are not equal. Okay, so let me write that. Since left-hand limit and right-hand limit, since left-hand limit and right-hand limit are not equal, the limit does not exist. So in this case, the limit as x approaches to 4 of h of x does not exist. See, you can see just like the first example, the function was not defined at 4. But in the first example, the limit exists. But in this one, limit does not exist. The simple reason is the left-hand limit and right-hand limit are not equal. So if the left-hand limit and right-hand limit are not equal, the limit does not exist. But remember one thing, this problem, this graph is unique to itself, because from the left and from the right, when we approach 4, when x approaches to 4, the function either approaches negative infinity or positive infinity. In such case, this vertical line x equal to 4 is the equation of the vertical asymptote. Okay, so in this example, a unique property here, this line here, this line, which is x equal to 4, is a vertical asymptote. It is vertical asymptote. So it's enough for you to prove that either the left-hand limit goes to infinity, it can be positive or negative, or right-hand limit is positive or negative infinity. If one of these is true, we can say that this vertical line is the vertical asymptote. So x equal to 4 is the equation of vertical asymptote. So just because of that, this graph is very unique to itself. Okay, if you think back one more time to the first example, the first example has a hole. It was not defined just because there was a hole. That's why we have this limit. Limit exists there, but there was no vertical asymptote. But in this one, although the function is not continuous or there is a break at 4, okay, limit does not exist simply because the left-hand limit and right-hand limit are not equal. But since the value of the limit is infinity, it can be positive or negative, that satisfies the condition that the vertical line going through that x value, so here is x equal to 4, is the vertical asymptote to the graph of that function. So you can see that limit is very powerful in telling you or helping you determine the vertical asymptotes, or it can also be horizontal asymptote sometimes, okay? So in this case, vertical asymptote to the graph of the function. So this is just the introductory video on limit. I hope you enjoyed the video. Thank you so much for watching. If you have any question, anything, you can reach out to me at any time. Okay. You can also comment, when this is streaming live and you're watching live, or if you want to go back and watch the recording in the future, you can always subscribe to this YouTube channel. And when you are watching later, if you have questions, feel free to reach out to me. I'll be more than happy to help you with your questions. Okay. Thank you one more